Hey y'all, it's Miss Johnson again. Second video of the day for me, perhaps second video of the day for you. I am gonna walk through the assignment, which is equations to graphs. It looks like this. You're given an equation and you're gonna graph it. You're given an equation in a slightly different form, you're gonna graph it. And then there's this part 3 that we'll go over where we're gonna preview going from x-intercepts to an equation. And that's just going to be like a small preview. But let's get to it. I'm going to go through this question and also write out the steps for each section, just so you have those notes, you've seen it done, and then you can try it on your own in the assignment. Okay. So for the first one, we've got an equation in factored form. Factored form means it has its two factors, x minus 6, x plus 2. The first thing you're going to do is multiply the equation together and write the equation in standard form, right? So this is the box multiplication. This is when we create a box. This box might have been too small. Put x minus 6 and x plus 2. Do the box multiplication, so multiply the thing on the top and to the left of each box. Write out the terms that you get, and then combine the two x terms to become negative 4x. Now, thanks to part A, we've got the equation in factored form, and we've got the equation in standard form. So whenever we go through the steps and it says, hey, put it in factored form or put it in standard form, we've got it. Okay, find the x-intercepts. Put them on the graph and label them with their coordinates. The first thing we're going to do is use the factored form, so the original form that we were given, and set each factor equal to 0. When we solve for x, we get 6 and 2, negative 2, meaning our two x-intercepts are 6, 0 and negative 2, 0. I'm going to go ahead and make these lines a little darker on the graph, just so I can see them. I'm going to go ahead and plot those on the graph. 1, 2, 3, 4, 5. I should have my glasses on. Negative 2. And I'll go ahead and label these as 6, 0 and negative 2, 0. Boom. Find the y-intercept. The y-intercept is, if we look in standard form, this is always the c of standard form. So I just know automatically it's negative 12 because I look at this back form. If I wanted to calculate it, I would plug in x equals 0. I would say then y equals 0 squared minus 4 times 0 minus 12, and we get that equals minus 12. So this y-intercept, we would go down 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I kind of baited y'all. It's way down here. Find the vertex. Put it on the graph and label it with its coordinates. So we find the vertex. This is the two-step process. First, we find what negative b over 2a is equal, and then we plug that into our equation. Notice we'll use standard form here, so we are going to use this format where a is 1 and b is negative 4. So the negative of negative 4 is 4. 2 times 1 is 2. 4 divided by 2 is 2. So the x-coordinate of our vertex is 2. And then when we plug in 2 to this, we get 2 squared is 4, minus 8 is negative 4, minus 12 is negative 16. And then when we graph this, it's actually like way down here. So my bad on the graphs. Y'all might want to count by 2s when you do these. And then draw in the parabola, connect the points with the U shape. Oh, I actually forgot to label these ones. Let me do so. And then I'll get my fourth color and draw in my parabola. All right. Let's type out the process for all of these, just so we have it in one place. Nope. Nice. Oh, we're getting there, guys. Y'all. 22. So, computers, am I right? Okay. To find x-intercepts, factor your quadratic. Set each factor equal to 0. Solve each mini equation. Answer looks like number comma 0 and number comma 0. For y-intercepts, it's always going to look like 0 comma c, where c is the last term of standard form. For the vertex, it's the x coordinate is negative b divided by 2a, where b is the middle coefficient for the, and a is the first coefficient. I cannot spell for standard form. I'm gonna have to scroll down to see if I'm actually spelling any of that right. Let's move this. So close. So once you find the x-coordinate by plugging in negative b over 2a, plug in that number to the equation to get the y-coordinate. So your answer will look like negative b over 2a, and then whatever that was when you plugged it in. And I'm going to... that's the worst thing that could have happened there. I will fix those for the notes. Ah, man, I really hate when that stuff happens. Okay. But that's the process for all three of those, and I'll rewrite the x-intercepts when I post the notes. The next question starts in standard form, and then you have to move it to factored form next. So here is when we would do the diamond. We'd say it multiplies to negative 5, adds to positive 4, so it's going to be 5 and negative 1. We can write this as x plus 5, x minus 1. And then the rest of the a through e, or whatever, are the same. It's the same process, just we want to change the forms first. Let me write this here. So eventually I can write the x stuff here. And then let's pause there. Now we know how to go from an equation that's in standard form or factored form. We can change the forms with each other, and we can find the x-coordinate, or the x-intercepts, the y-intercepts, and the vertex for each of these equations, right? And then once we have those 4 points, we can plot them on a graph, and then connect the dots and graph our parabolas. That's pretty good. The next thing we're going to try to do is, if we're given some of these points, so if we're previewing going from the graph to the equation, if we're given some of these points, how would we make the equation? Up here, we noticed that when our factors were, 6 and 2? When our factors looked like this, right? When the factors look like this, the x-intercepts looked like this. So the negative 6 turned into a positive 6, and the plus 2 turned into a minus 2. When we come over here, we're doing it backwards, right? So instead of going from here to here, we're starting with our intercepts and we're going back to our factored form. So here, if our intercepts are -7 and +3, we would expect our factors to be +7, -3. I'm going to do it again over here. If our intercepts are 0 and 4, we're expecting our factors to be -0 and -4. The 0 one's a little funny because we can just write this as x. You basically never need to write -0, right? And then both of these we could multiply out with the box and write them in standard form instead. Either one of these would be the right answer for this question. The fun part about going backwards, and this is kind of where the worksheet stops, but here's a fun fact. The fun fact about going backwards is if I have -7 and 3, I also could have made these factors x plus 7, fine, and 2x plus 6, minus 6. Right? Basically taking this factor and multiplying both of them by 2. The reason I know I can do that is if I check my work by setting each of these equal to 0. Nope. This still gives me -7. Good. This one, I'm going to add 6 to both sides, and then I'm going to divide by 3. This one also still gives me 3, right? So it turns out that when we're making an equation with just the 2x intercepts, it's not enough to give us a unique equation, because this equation and this equation are not the same, right? They have different graphs, but they do have the same x-intercepts. And what that's going to look like on the graph is one of them is going to look like this with these two intercepts, and the other is going to look like this, where it's the same intercepts, but it's like stretched out. And this is what we'll be talking about on Thursday. Let me redo that. There you go. That should set you up for this work nicely. Let me know if you have any questions. Email me, come to office hours, reach out, and I will see y'all on Thursday.